Hello class, this will be our last video. This is going to cover chapter 10. We're going to take a look at trigonometry. Now we've already taken a look at measuring angles in degrees. For example, this could be 45 degrees. Now we're going to take a look at measuring things in radians. 1 radian is equal to 180 degrees divided by pi. Where this comes from is if I have a circle, that circle has a given radius, we'll call that r. If I take the length of that radius and start going around the circle, here would be about 1 radius, here would be about 2 radius, 3 radii, and then right at halfway around the circle, I have pi of the radius around, and if I finish going all the way around, I then have 2 pi of that radius. So measuring things in radians, right, here we see halfway around the circle is about the same as pi of our radii, right, and that's going to be now pi radians, and we see here this ratio showing that pi equivalent to 180 degrees. So for example, if I have that 45 degrees, if I want to convert 45 degrees into radians, I can multiply this by a ratio of pi and 180 degrees, keeping degrees on the bottom so that my measurement of degrees cancel out, and pi up top. This gives me pi over 4 radians. So 45 degrees then is equivalent to pi over 4 radians, or if I've gone 45 degrees around that circle, it's the same as tracing pi over 4 of the radius around that circle. The way this works out is anytime I want to go from degrees to radians, say for example converting 60 degrees into radians, I will always multiply by the ratio of pi over 180. If then I'm going from radians to degrees, so for example I have a measurement of pi over 2 radians, and I want to convert to degrees, I multiply by the reciprocal of that ratio, 180 over pi. So converting 60 degrees into radians, I multiply that by my pi over 180. 60 divided by my 180 gives me 1/3 times that pi. I have pi over 3 radians. And then here pi over 2 radians times 180 over pi. My pi's cancel out, and I'm left with 180 divided by 2, which gives me 90 degrees. So we see here pi over 2 radians is equivalent to 90 degrees, and 60 degrees is equivalent to pi over 3 radians. Where radians are especially useful is in measuring the arc length around a circle. If I have some circle with a radius r and an angle A, where A is measured in radians, I can then find the arc length being the distance along the circle from this point to this point, we'll call that S. That arc length, S, is equal to A times R, again where A is measured in radians. So if I have a circle where my radius is 16 inches and the angle that I'm looking at is 150 degrees, I can then calculate the length along that part of the circle using this formula. The first thing I'd have to do though is convert this 150 degrees into radians. Again, if I'm converting degrees into radians, I always want to multiply by pi over 180 degrees. Again, always my degrees should cancel out, so if I'm converting from degrees to radians, degrees should be in the bottom of my ratio. So I multiply this together, and I get 5 pi over 6 as my measurement in radians. So to find my arc length, S is equal to 5 pi over 6 multiplied by my radius of 16 inches. Multiplying that all out, I find that my arc length, S, is equal to about 41.9 inches. That is the length then of that part of the circle. I can then use this to find the area of that slice. For example, if this were a pizza with a radius of 16 inches, can find the area of that slice of pizza, knowing now my arc length, area for a segment of a circle like this is equal to 1/2 the radius squared times my angle in radians. This is also equal to 1/2 r times s. So I can use either one of these formulas to find the area of that slice of pizza. If we go ahead and plug in these numbers, 1/2 of 16 times 41.9, we should get about 335 inches squared for the area of that slice of pizza. Next, we're going to take a look at the difference between linear speed and angular speed. Linear speed is what we're used to. If I travel some set distance, say 60 miles, and I travel that 60 miles in 1 hour, my velocity or my speed is my distance divided by my time, so I'm then traveling at 60 miles per hour. Angular speed is a measurement of how many degrees you've traveled around a circle given a certain amount of time. So for example here, if I travel this 80 degrees around the circle in a certain amount of time, it doesn't matter if I travel along this path or along this path. They both have the exact same angular speed because it's not dependent upon how far I am from the center. It's not dependent upon a radius, just on an angle and a time. So my linear speed, right, is the measurement of distance per time. So when I'm closer to the center, I've traveled less distance. So I have a smaller linear speed down here as opposed to this longer arc here. However, my angular speed for both is exactly the same. The measurement of my angle in radians, which I'll have to convert, per time. So if I travel that 80 degrees in, say, 2 seconds, my angular speed then, first I need to convert my 80 degrees into radians, so I multiply by pi over 180. This gives me 4 pi over 9. So that is my angle in radians. Then my angular speed, W, is 4 pi over 9 divided by 2 seconds. This is the same as 4 pi over 9 times 1/2. So my angular speed is 2 pi over 9 radians per second, which is about 0.70 radians per second. So that is my difference between linear speed and angular speed. Next, let's take a look at a triangle. We know that the leg opposite the 90 degrees is always called the hypotenuse. So we have our hypotenuse and we have two other legs. We can define these other legs in relation to one angle of that triangle, an angle other than the 90 degrees. We have, for this angle, the side opposite that angle, and then we would have this side here, right? This side right next to the angle that is not the hypotenuse. This side would be then the adjacent side. So with respect to this angle, we have the opposite side from that angle, the adjacent side from that angle, and the hypotenuse, which is always the same. It's always opposite our 90-degree angle. We can use these definitions of sides for our trigonometric functions. So if I have some angle A here, the sine of that angle A is equal to the opposite side over the hypotenuse of that triangle. So say, for example, I have the triangle with measurements 3 inches, 4 inches, and 5 inches. The sine of angle A, would be equal to the opposite side of 3 over the hypotenuse of 5. So the sine of A is equal to 3/5. This corresponds to the angle A equal to about 36.9 degrees. So if you were to plug into your calculator the sine of 36.9 degrees, you would find that that is about equal to 3/5, or about 0.6. The sine of an angle is always the same regardless of the lengths of the sides. So for example, if I did not know one of the lengths of the sides of this triangle, I can find the sine of the angle, and with the other side that I know, I can then calculate the remaining side's length. Let's take a look at that. So if I know that A is 30 degrees, and I know that the opposite side from it is 1 inch in length, I can then calculate the length of my hypotenuse knowing the sine of the angle. I know that the sine of 30 degrees then should be its opposite length, 1, over the length of the hypotenuse. We'll call that h for now. So the sine of 30 degrees is 1/2, and that is equal to 1 over h. I can then solve for h. I can multiply both sides of this equation by h to get out of the denominator. I then have h over 2 is equal to 1. Multiply both sides by 2 to get h by itself, and I have h is equal to 2 inches. So I know my hypotenuse is 2 inches. Another trigonometric function is the cosine of an angle. The cosine is equal to the adjacent side over the hypotenuse of the triangle. So for example, let's say I had an angle of 60 degrees now, and I know that the adjacent side is 4.5 inches. I can then find my hypotenuse using the cosine of that angle. The cosine of 60 degrees is equal to the adjacent side, 4.5, over the hypotenuse, again, h. Cosine of 60 degrees is 1/2, which is equal to that 4.5 over h. Another way I can solve this type of proportion is using cross multiplication. I can multiply diagonally, and I have h times 1, which is h, is equal to 2 times 4.5, which gives me 9. So I find here that the hypotenuse is 9 inches long, when the adjacent side to a 60-degree angle is 4.5 inches. Lastly, I have the tangent of an angle is equal to the opposite side over the adjacent side. So if I know that this angle here is 45 degrees, and I know the adjacent side is 5 inches, I can find the opposite side using the formula for tangent. Tangent of 45 degrees is equal to the opposite side, we'll call that x, over the adjacent side of 5 inches. The tangent of 45 is equal to 1, which is equal to x over 5. Can multiply both sides by 5 to get x by itself, and I have 5 inches is equal to x. So we find here that the opposite side is 5 inches. One handy tool is called the inverse function. An inverse function, for example, the inverse tangent function, written like this, the inverse tangent then takes the opposite over the adjacent side and gives me back the angle. So the inverse tangent function, if I wanted to find the inverse tangent of 5 over 5, right, finding the inverse tangent of 1, it would give me back 45 degrees. So this function can be found usually right above your tangent button on the calculator. You just have to hit your second button and then the tangent button in order to get the inverse tangent function. Another way you might see this set up is if you had the tangent of A was equal to the opposite over adjacent, or 5 over 5. Now in order to find A, you take the inverse tangent of both sides. The inverse tangent of tangent is just A, and then I'm left with the inverse tangent of 1. This then, the inverse tangent of 1, gives me that A is equal to 45 degrees. So just two different ways of saying the same thing. There's two different ways that you might see that set up. So, using what I know about triangles and the sine, cosine, and tangent functions, I can then find all of the measurements of this triangle. I can find the other missing angle and the two missing sides, finding the other leg and the hypotenuse of the triangle. So the easiest thing to find is always that other missing angle. Since the measurement of all three angles always adds up to 180 degrees, I know this angle is 90 and this one's 22. This one then has to be 68 degrees. Now I can find the other two sides. If I want to find this side, we'll call this B. Then this side we can find either by using the tangent function, using our 22 degrees, the tangent of 22 being equal to the opposite over the adjacent side, or I can use the tangent of 68 degrees where the opposite is B over 36. It's usually easiest to solve it when I have the unknown as my numerator. So I'm going to go ahead and use the tangent of 68 degrees to find B over my adjacent side of 36. The tangent of 68 degrees is about 2.475, which is equal to our B over 36. I multiply both sides by 36, and I find that B is about 89.1. My units are in feet. So I have 89.1 feet here. Now, to find the hypotenuse, I usually want to find it using measurements that I know are exact. Since 89.1 feet was an approximate measurement, I wanted to use my 36 and hypotenuse with one of these two angles that I know is exact. So for example, I could use the sine of 22 degrees is equal to its opposite, 36, over the hypotenuse we'll call x. Or I could use the cosine of 68 degrees, where the cosine of 68 is equal to its adjacent over the hypotenuse. Again, using measurements that I know are exact. So here we'll do the sine of 22 is equal to its opposite, 36, over the hypotenuse, x. In this case, solving for the hypotenuse, there is no formula that has the hypotenuse as its numerator, so we have to use one where it's in the denominator. So the sine of 22 degrees is about 0.375, which is equal to our 36 over x. Again, I can use cross multiplication here, treating this as 0.375 over 1. I cross multiply and find that 0.375x is equal to 36. Divide both sides by that 0.375, and I find that x is equal to about 96.1 feet. So we have our hypotenuse now at 96.1 feet. Now if you try this, take 36 divided by 0.375, you won't get exactly 96.1. What I did to get that is I used my 36 divided by the exact answer that I found in my calculator. That number was more precisely 0.3746065934. Okay, that is what my calculator gave me, and that's what I used to find my answer. So again, I never want to round my answers until the very last moment. So for example, I can round this to 96.1 feet, And I know that this will be more exact, knowing that I have not rounded my previous answers. I round them just when I write them out, because it would take forever to write out the entire number every single time. But again, I want to use my exact answers that my calculator saves to find my final answer. The rules we just looked at always use a right triangle. However, we do not always have a right triangle to look at. If we have a triangle like this, right, something that does not have a 90-degree angle, we can consider our angles A, B, and C, and their sides opposite them, little a, little b, and little c. We can then use what is called the law of sines in order to find relationships between all of these angles and sides. What we find is that the sine of an angle over its opposite side is equal to the sine of any other angle over its opposite side. So if I have a triangle with these measurements, I can find the remaining measurements using my law of sines. First, I can find the remaining angle, knowing again that 180 degrees is the sum of all angles in any triangle. So 98 plus my 52 gives me 150, leaving 30 degrees for that remaining angle. Now, using the law of sines and knowing one of the sides of the triangle, I can find the remaining sides. So let's go ahead and start and find this side A. I know that the sine of 52 degrees over that side A has to be equal to the sine of my 98 degrees over 6. I always want to have one ratio that is complete. So the sine of 98 degrees over 6, I can calculate these exactly, and then I only have one missing piece to solve for. So I can use cross multiplication here to solve for A. I have A times the sine of 98 is equal to 6 times the sine of 52. To solve for A, I can divide both sides by the sine of 98 degrees. So I have here sine of 98 cancels out, and I have A is equal to 6 times the sine of 52 over the sine of 98, all of which I can plug in. This gives me about 4.77 in my units of feet. So side A is about 4.77 feet. Now I can again use my law of sines to find my one last remaining angle, B. So here, to find B, I can know that the sine of 30 degrees over B is equal to, and now that I have solved for one of the other sides, I could use the sine of A over 4.77. But again, I know that this answer is not exact, so I want to use the two that I do know are exact. So I'm going to reuse that sine of 98 over 6. I cross multiply again to get B times the sine of 98 is equal to 6 times the sine of 30. So B is equal to 6 sine 30 all over the sine of 98. This is about equal to 3.03 feet. So I now know B is 3.03 feet, and I have solved for all of the angles and sides of that triangle using my law of sines. The law of sines is only helpful when we have at least one angle and one side that is opposite each other, and one other measurement to begin off of. We do not always have an angle and its opposite side. For example, we could have two sides and an angle that is not opposite either side, or we could just have all three sides and no angles. We need another law in order to solve that type of triangle. This formula is called the law of cosines, where if you do not have a side and an angle opposite each other, if you do not know both of their measurements, you can find one if you know the other two sides. So if I want to know the length of A, and I have the measurement of B, C, and angle A, I can plug that into this formula, and find the length of that missing side. This also works if I had all three sides. I could then find the angle opposite A by plugging in the length of all three sides into here and then solving for the cosine of A. Once I have some number equal to the cosine of A, I would then take the inverse cosine of whatever answer I had in order to find my angle A. So if I have a triangle like this where I know all three sides and I want to find a missing angle, I can then plug it into this formula to find that angle. Let's go and find angle A. So plugging that in, I have 6.95 squared is equal to 9.33 squared plus 7.24 squared minus 2 times 9.33 times 7.24 times the cosine of angle A. So I want to get cosine of A by itself, which means first I will subtract out these two terms from both sides. So subtracting 9.33 squared and 7.24 squared from both sides of this equation, right? 6.95 squared minus 9.33 squared minus 7.24 squared gives me a negative 91.164, and that is equal to my negative 2 times 9.33 times 7.24 times the cosine of A. So this first part here gives me a negative 135.0984 times the cosine of A. Now I divide both sides by that negative 135.0984. This is about 0.675, which is equal to my cosine of A. And this is not exact, but I have saved the exact number in my calculator, about 0.674797, so on and so forth. Now, to find A, I take the inverse cosine of both of these. Right, so the inverse cosine of 0.675 should be equal to that measurement of A. So angle A is equal to about 47.56 degrees. So that is my angle A in degrees. I could do the same for angle B and angle C. Again, just switching up my numbers here just to make sure if I was solving for C, right, angle C would go here, and then my side C would go here. So I'd have B squared plus A squared minus 2BA cosine of C. Again, just so that the side and angle opposite are those two parts, and the other two sides are these two sides within my formula. Let's go ahead and solve one more where we find side C here given these two sides and an angle. So C squared then would be equal to my A squared, 8.5 squared, plus my 6.2 squared minus 2 times 8.5 times 6.2 times the cosine of 41 degrees. Now all I have to do is solve everything here, and that will tell me what C squared is equal to. 8.5 squared plus 6.2 squared gives me 110.69, and then minus 2 times 8.5 times 6.2 times the cosine of 41 gives me about minus 79.55. I now subtract those two, and C squared is equal to about 31.14. Now to find C, I have to take the square root of both sides, and I find that C is equal to about 5.58, and my units are in meters. So I have C is 5.58 meters. That will do it for Chapter 10. Be sure to take notes and bring your homework and your questions to class. I will see you then.